All right, so let's go ahead and get started. We have a relatively short lesson today, but it is one that often trips people up, so I want to take our time with it. We are going to talk about how to solve for a variable, so solving for a variable. Now, everything that we've done so far, all the algebraic equations that we've done so far, have only involved one variable. They've involved usually the letter x, but sometimes k, y. It doesn't really matter, right? Any variable stands in for any unknown number. What's the difference between the equations we've looked at so far and the 4 examples I have up on the board right now? There's what? More than one variable, right? There's more than one variable going on. In example number 1 here, this y equals mx plus b, there's actually 4 variables. So am I going to be able to, quote unquote, solve it? No. Why not? I don't know anything, right? Or I don't know enough. I don't know what any of those variables are. So essentially, I could just plug in any random numbers and make it work, but that's not really solving it, right? So what we're talking about today is how to solve something, quote, in terms of. So for instance, right now, this equation is in terms of y. This equation is in terms of f. This one is in terms of e. What does that mean then? If I tell you that, then what do you think it means to be in terms of? So if I say this one is in terms of y, this one is in terms of f, and this one is in terms of e, what do you think that means? David? No, not necessarily how to solve it, because remember we said we can't solve it because there's like 4 variables in there. That's what it equals. That's the one that's currently isolated. So what we've been doing so far, for example, in rewind number 1, what did you solve for? R. And you got it so that it broke down to R equals, I think it was 2, right? Was R 2? Yeah, so R was equal to 2. So that was done in terms of R, because at the very end, you got it down to R equals something. In this case, we can't break it down much more, but we have it in terms of y, because it's broken down to y equals something, okay? And that thing, in this case, is mx plus b. So it's not just one number, but it's in terms of y, because that's what's by itself. So what we're talking about today is how to isolate variables when all your other stuff is not necessarily numbers, it's also other variables. So take a look again at this y equals mx plus b. Let's look at that one a little closer. What if I said solve for m? What do you think it would mean if I said solve this for m? Don't tell me how to do it, but what do you think that means? What do you think it means if I say solve for m? Jesse? Get the m by itself. So I want the m to be alone instead of the y to be alone. So instead of getting y by itself, because we already have y by itself, I want to try to get m by itself, which means what do I have to get rid of? The b and the x, because the b and the x are currently with the m, and we want to get rid of them. The process of doing this is no different than the algebra that we've done for the past 2 days. The only difference is it's not going to look as neat because stuff doesn't disappear because you can't really combine like terms. That's okay. The process is still the same. So I'm looking at this, and I want to get m by itself, which means I need to get rid of the x, and I need to get rid of the b. Think back to yesterday. Which one do I want to get rid of first? Elijah? The b. The b is my weak antelope, right? Why is the b the weak antelope here? Because it's the farthest away. It's by itself, so I can get rid of it. How do I get rid of a plus b? I just do a minus b, right? So minus b here. If I do it on one side of my wall, where else do I do it? The other side, so underneath here. Now here's where this just gets a little tricky. Can you do this? No, why not? They're not like terms. So it's tricky in that you can't do anything, but it's easier because it's like, well, I can't do anything. So I just write it as y minus b. That's it. You can't do anything with it, so it's just y minus b. Now what do I have left over here? Mx. And again, I want to solve for m, which means I want m alone. So now I have to get rid of the x. What kind of math is this? multiplication. So how would I get rid of it? So I'm going to divide by x. And if I do it here, where else do I do it? What am I dividing by x? The y, the b, or the whole thing? The whole thing. So my line goes underneath the whole thing. Now what happens to my x's here? They're gone. So what do I have left? M. And then can I do anything here? No. So again, it's harder in that it doesn't just disappear, but it's easier because really all you're doing then is recopying this. There's nothing you can do, so that's it. Now it's in terms of m. Now we've solved for m. So my equation is m equals y minus b over x. And that's all you can do. That's done. That's as simple as it can get. So there's your answer. All right, so the process is no different. The only change is that in all the ones we've done before, we've been doing actual arithmetic and actual math. So there's less math to this, but you have to be able to still apply the same rules and the same process. Okay, so we just did that. All right, so take this one. This one says solve in terms of c. So that means what do I want to do? I want to get c by itself. This one has some numbers in it, which might make it easier, might make it a little bit harder. I'm going to write this a little bit differently. I'm going to write it as f equals 9/5 c plus 32. My computer won't let me write this as a fraction, so it looks like a slash, but it's really a fraction. So then ask yourself, if I want to solve in terms of c, what am I, quote unquote, getting rid of? The 32 and the 9/5, right? Which one do I have to get rid of first? I'm hearing either one. I can't get rid of the 32 yet. All right, remember, how do I solve inverse operations? I use, instead of PEMDAS, I go SADMAP. So the last thing I can do is the stuff that's inside the parentheses. So first, before I get rid of anything inside the parentheses, I have to get rid of the 9/5. Well, how do I get rid of a fraction? Multiply by its reciprocal, which is a fancy word for flipped. So instead of multiplying by 9/5, I'm going to multiply by 5/9. Very good. So I'm going to put it over here because I can't fit it right in here. But really, what are these two things going to do? Cancel out. If I do it on this side, what do I do over here? Same exact thing. So times 5/9. All right, now I'm just going to cross these out. And again, if the 5 is on the bottom, that's why I have to flip it, right? Because to cancel it out, I need it on the top. So what do I have left on this side now? C plus 32. Do I need my parentheses anymore? No, because I don't have anything else over there, so I don't need them. What does this give me? Five ninths F. Can I do any math there? No, there's nothing you can do there. That's just it. 5/9 F. Okay? Now, how do I get rid of a plus 32? Minus 32. If I do minus 32 here, what do I do here? Minus 32. What happens here? Those go away. What do I have left? C. And this is where you're like, that looks really hard. It does look really hard, right? But are these like terms? No. So can I do anything? No. So I'm not making it hard because all I have to do is just copy this. 5/9 F minus 32. And that's all you can do. They aren't like terms. So there's no math to even do here. So when you're looking at this, people always think like, oh, these problems are so much harder. There's actually no math to do. You're just recopying stuff. You're shuffling stuff around and you're recopying it. You just have to remember, the only thing we really had to remember here was what? How to get rid of a fraction. So multiply by the reciprocal. That's the only thing you really had to remember. Other than that, we're just rewriting it. Does this get any shorter? No, so your answer should still be pretty long. All right, you're not really solving it. You're just trying to get a variable where. by itself. And it's just a different variable than the one that they have by itself to begin with. Okay? So when you look at these problems, my advice to you is, first of all, understand your answer is probably going to be just as long as the question was. So if your answer is like 5 equals x, you've done something wrong, because you shouldn't really be able to make anything disappear. And then should you be doing a ton of math here? No, not really. You're just basically copying things in different spots. Okay, so I would like you to try these. It says, when you look at these, it says, like, number 1, solve d equals rt. So here is your equation, d equals rt. And then it'll tell you right here which variable you're trying to get by itself. Okay, so that says 4r, which means I'm trying to get r by itself. Does that make sense? Okay, so all the ones like here, 4p, that means you want the little p by itself. Here, you want the c by itself. Here, you want the b by itself. Okay? All right, so try those at your boards.